The Intergalactic Chemistry Academy floated in orbit around the frozen planet, Zephyria 7, a gleaming structure of interconnected pods, rotating around a central hub. Through the vast observation windows, the planet's icy surface glimmered like a diamond against the backdrop of endless space. The Academy was home to the brightest chemical minds from across 17 star systems, a beacon of scientific excellence that attracted scholars from civilizations, both ancient and emerging. Among them was Cadet Mara Lee, the lone human representative in the Advanced Theoretical Applications program. She stood at the viewport in Laboratory Pod 7, watching the slow rotation of the Academy against the stars, her reflection superimposed upon the cosmos. At 26 Earth years, she was considered practically an infant by most species standards, and the representative of what many considered a barely spacefaring civilization. Enjoying the view while the rest of us work, Terran. The crystalline voice came from behind her, the tonal frequencies slightly off in a way that human ears found jarring. Mara turned to face Kellis, a Zelvan student whose silicon-based crystalline form refracted the laboratory lights into prism patterns across the floor. Like all Zelvans, Kellis communicated through controlled vibrations of his crystalline structure, the sounds translated by the universal communicators everyone wore at the Academy. "Just gathering my thoughts," Mara replied, her hand instinctively touching the small earth pin on her uniform collar. A reminder of home and why she was here. To prove humanity's place among the stars wasn't just a fluke of faster-than-light technology acquisition. Kellis made a sound like breaking glass, which the translator unhelpfully rendered as laughter. "What thoughts could possibly help your primitive chemical understanding? Your species only discovered quantum entanglement 3 centuries ago. We've been manipulating subatomic bonds since before your kind walked upright." Mara had heard variations of this sentiment since arriving 6 months ago. Earth was the newcomer, the upstart, the species that many felt had been admitted to the Academy too soon. Most alien students saw humans as scientifically backward, still relying on combustion and reduction where others used quantum manipulation and dimensional folding. She opened her mouth to respond when the laboratory doors slid open with a soft, pneumatic hiss, revealing Professor Xanthor. The Zelvan instructor towered nearly 3 meters tall, his crystalline body a complex structure of interconnected formations that had grown more elaborate with his 800 years of age. Each facet caught the light differently, creating a kaleidoscope effect that many species found disorienting. Unlike younger Zelvans like Kellis, whose forms were relatively simple, Professor Xanthor's body told the story of his accumulated knowledge in its complex geometric patterns. The professor's arrival silenced the 23 students from 17 different species. Even in the low-gravity environment of the laboratory, his presence seemed to carry weight. Phase 3. Evaluations will commence in exactly 72 hours, announced Professor Xanthor, his voice resonating throughout the chamber without need for amplification. "Your assignment is simple in conception, but will test the depths of your understanding." The RQ teaching drones, small, spherical devices with multiple sensor arrays, floated around the room, recording the professor's words and the students' reactions for later analysis. "You will create a chemical reaction that demonstrates purity of concept," continued Xanthor, moving to the center of the laboratory, where a holographic display activated at his approach. "The reaction must utilize only stable, safe compounds. No exotic materials, no biological components, no external energy sources beyond standard activation. Simply solutions and basic salts, combining to create something worthy of note." Mara felt her heart sink. Chemical reactions without biological components or energy manipulation. Earth's chemistry was based almost entirely on organic compounds and energy transfer. Around her, she noticed several other students from carbon-based species shifting uncomfortably. "The purpose," Professor Xanthor continued, his facets catching the light as he turned, is to demonstrate mastery of fundamental principles. Too often, we rely on complex systems and exotic components when the true elegance of chemistry lies in the basics. Your reactions will be judged on efficiency, theoretical insight, and practical application. Mara watched as the holographic display filled with examples of previous years' winning entries. Complex crystallization patterns, color-changing solutions that formed precise geometric shapes, gases that coalesced into visible mathematical equations. All of them seemed far beyond what she could achieve with Earth chemistry. You have access to the Academy's full chemical repository, Xanthor concluded. Choose wisely. Dismissed. As the students dispersed, Mara remained rooted in place, staring at the holographic examples. How could she possibly compete with species that had been manipulating matter at the molecular level for millennia? Don't worry, human, said a voice like bubbling liquid. Mara turned to see Triz, a Vorian student whose gelatinous body contained visible currents of bioluminescent fluid. Vorians were known for their expertise in light-emitting chemical reactions. Perhaps you can show us how your people make fire. That would be educational for all of us. Several nearby students made their species equivalent of laughter. Mara forced a smile, refusing to show how deeply the mockery cut. 6 months at the Academy had taught her that showing weakness only invited more derision. I'll come up with something, she said, projecting confidence she didn't feel. I'm sure it will be primitive, Triz replied, the bioluminescent patterns in his body forming shapes that Vorians recognized as amusement. As the laboratory emptied, Mara approached the central terminal to access the chemical repository database. Her fingers hovered over the holographic interface, hesitating. What could she possibly create that would impress beings who considered Earth chemistry as primitive as stone tools? The database contained millions of compounds from across the known galaxy, categorized by planetary origin, atomic structure, and potential applications. Mara narrowed her search to Earth origin compounds, knowing that working with familiar materials would be her only advantage. The list that appeared was depressingly short compared to the vast array of extraterrestrial chemicals available. Water, carbon dioxide, sodium bicarbonate, acetic acid, citric acid, sodium chloride, potassium nitrate. Mara paused, her eyes lingering on sodium bicarbonate and acetic acid. Baking soda and vinegar, the components of every child's first volcano science project on Earth. Her initial reaction was dismissal. Surely she couldn't present something so elementary to the Intergalactic Chemistry Academy. But something about the simplicity tugged at her mind. Professor Xanthor had emphasized purity of concept and fundamental principles. What was more fundamental than an acid-base reaction? The challenge would be presenting it in a way that demonstrated deeper understanding rather than elementary school science. Mara began a new search. This time, looking up the previous experiments conducted by other species using simple acid-base reactions. The results were sparse. Such basic chemistry was apparently beneath the notice of most advanced civilizations. This, she realized with growing excitement, might actually be her advantage. For the next several hours, Mara remained at the terminal, researching and planning. By the time the laboratory's lighting dimmed to simulate night cycle, she had requested samples of sodium bicarbonate, acetic acid, and several other Earth compounds from the repository, along with basic laboratory equipment. As she headed back to her quarters, Mara felt a strange confidence building. The other students would be creating elaborate, flashy demonstrations, competing to outdo each other with complexity. She would go in the opposite direction, finding profound insight in simplicity. Back in her small living pod, Mara pulled up a three-dimensional projection of her concept. The basic reaction was simple: sodium bicarbonate and acetic acid combining to produce water, carbon dioxide, and sodium acetate. But her planned execution was anything but basic. She would create a system of precisely calibrated delivery tubes, timed release mechanisms, and carefully shaped containers. The carbon dioxide release would be controlled to create specific pressure differentials. The entire setup would be designed to work in the Academy's low-gravity environment, where fluid dynamics behave differently than on Earth. For the next 2 days, Mara barely slept. When not attending mandatory lectures, she was in the laboratory, constructing her apparatus. She fabricated narrow tubes with precise internal dimensions, built pressure sensors accurate to the micropascal, and programmed timing mechanisms to coordinate the release of chemicals down to the millisecond. The other students cast curious glances at her work, but most paid her little attention. They were focused on their own creations, which were growing increasingly elaborate. Kelly's was working with what appeared to be superheated plasma contained within magnetic fields. Triz had created crystals that emitted different frequencies of light based on surrounding chemical compositions. A Trelax student named Vorn had somehow engineered self-organizing neon gas that formed complex molecular structures when exposed to specific sound frequencies. Compared to these displays of advanced chemical manipulation, Mara's setup of tubes, containers, and basic earth chemicals seemed primitive. She overheard whispers and translated laughter, but forced herself to ignore them, focusing instead on the precise calibration of her equipment. On the morning of the evaluation, Laboratory Pod 7 was transformed. The central area had been cleared, with presentation platforms arranged in a circle. Each student would have exactly 10 minutes to demonstrate their reaction and explain its significance. Mara arrived early to set up her apparatus, carefully positioning each component and running final diagnostics on her timing systems. As the other students arrived and began their preparations, she noticed several casting dismissive glances at her simple setup. "Is that it?" asked Kellis, vibrating with what the translator rendered as incredulity. "Tubes and containers? What millennium do you think this is?" "Sometimes the simplest approaches reveal the most profound truths," Mara replied. An Earth, saying her grandmother had often repeated. Kellis made that glass-breaking sound again. "We shall see, Terran. We shall see." Professor Xanthor arrived precisely on schedule, his crystalline form even more elaborate than usual, a sign of formal occasion among Zelvans. The RQ drones swarmed around him, recording every detail of the proceedings. "We begin with Kellis," announced the professor, gesturing to the first platform. Kellis moved to his station and activated his apparatus. Instantly, a swirling vortex of plasma formed within the magnetic containment field, changing colors as different elements were introduced to the reaction. The plasma formed complex patterns, eventually stabilizing into a perfect replica of the Zelvan home star system, complete with orbital mechanics demonstrated through plasma flow. The intersection of plasma dynamics and gravitational simulation demonstrates the underlying unity of astronomical and chemical principles, Kellis explained, his crystalline form vibrating with pride. The demonstration earned appreciative sounds from the assembled students, and a slight incline of Professor Xanthor's upper facets, the Zelvan equivalent of an approving nod. One by one, the students presented their projects. Triz's light-emitting crystals formed a display that mapped quantum states through color variations. Vorn's neon structures assembled themselves into progressively more complex molecular arrangements, eventually creating a miniature working model of a theoretical faster-than-light drive component. Each demonstration seemed more impressive than the last, employing principles of chemistry that humans had yet to discover or master. Mara felt her confidence wavering as her turn approached. Her simple acid-base reaction seemed increasingly inadequate compared to the marvels she had witnessed. When only 2 students remained before her turn, disaster struck several platforms away. A Heliac student's demonstration of atmospheric compression suddenly went awry, releasing a cloud of greenish gas that rapidly expanded in the low-gravity environment. The Academy's safety systems immediately activated, neutralizing the gas, but not before it had reached several nearby stations, including Triz's. The Vorian's carefully calibrated crystals absorbed some of the gas, causing them to emit unexpected frequencies of light. This light, in turn, affected Vorn's neon structures, which began to vibrate at unusual frequencies. A chain reaction of minor disruptions spread across the laboratory, each project influencing others in unforeseen ways. Professor Xanthor raised his arms, crystalline structure vibrating with authority. Remain calm. Safety protocols are functioning. Continue with the demonstrations, accounting for any alterations to your setups. Mara quickly checked her apparatus and discovered that the unexpected gas release had changed the ambient conditions in the laboratory. The pressure and humidity were different from her calculations. She made rapid adjustments to her timing mechanisms, recalibrating for the new conditions. When her turn finally came, Mara approached her platform with her heart pounding. The other students had grown quiet, their initial mockery replaced by curiosity about what the human would present. "My demonstration," Mara began, her voice steadier than she felt, "explores the fundamental nature of acid-base reactions, specifically sodium bicarbonate and acetic acid, in a precisely controlled environment." She activated her apparatus. At first, nothing seemed to happen. No dramatic light show, no swirling plasma, no self-organizing structures, just a series of tubes through which clear liquids began to flow. Several students made dismissive sounds, but Professor Xanthor remained silent, his multifaceted form completely still as he observed. The liquids met at precisely calculated junctions, mixing in exactly the right proportions. As the chemical reaction began, carbon dioxide was released, creating pressure that pushed the resulting solution through another series of tubes. White foam began to form, flowing upward through spiral tubes that used the low gravity to create a mesmerizing pattern of ascent. But this was merely the beginning. The foam, upon reaching certain height thresholds, triggered secondary releases of diluted citric acid mixed with sodium chloride. These entered the reaction at precise moments, creating waves of foam that rose and fell in a rhythm that mimicked the mathematical sequence of prime numbers. The released carbon dioxide, meanwhile, was not wasted. Mara had designed a collection system that captured the gas and channeled it through a series of increasingly narrow tubes. The pressure built until the gas escaped through tiny apertures arranged in a circular pattern. This was where the unexpected atmospheric changes worked in Mara's favor. The escaped carbon dioxide interacted with the trace elements still lingering in the air from the earlier accident. Instead of simply dispersing, the gas created visible currents that caught the laboratory lights, refracting them into subtle, shifting patterns above the foam display. The remnant gases from Triz's light-emitting crystals interacted with Mara's carbon dioxide release, creating faint, bioluminescent eddies that swirled in counter-rhythm to her foam display. The vibrations from Vorn's neon structures, still resonating at unusual frequencies, caused harmonic patterns in the foam's movement, amplifying the mathematical precision of her design. What had begun as a simple acid-base reaction had transformed into a complex, interconnected display that incorporated elements from across the laboratory. The foam rose and fell in perfect mathematical sequences. The gas release created light patterns that danced in counterpoint, and the entire system pulsed with a rhythm that somehow felt both ordered and organic. The laboratory had fallen completely silent. Even the RQ drones seemed to hover motionless, their sensors fully focused on Mara's display. As the reaction reached its final phase, the foam began to recede. The carbon dioxide release slowed, and the light patterns gradually faded. The entire demonstration had lasted exactly the allotted 10 minutes, ending with the system returning to its initial state, ready to begin again. Mara looked up from her apparatus to find every eye, visual sensor, and perception organ in the room fixed upon her. Professor Xanthor's crystalline form remained perfectly still, a sign of intense focus among Zelvans. The significance, Mara explained into the silence, lies not in the complexity of the chemicals used, but in the precision of their application. This demonstration shows that even the most fundamental reactions can create complex, adaptive systems when properly understood and controlled. It also demonstrates the interconnected nature of all chemical processes, how each reaction influences and is influenced by its environment in ways that can be both predicted and harnessed. She paused, then added, "On Earth, this reaction is often a child's first introduction to chemistry. I wanted to show that there is profound depth, even in what we consider elementary, if only we look closely enough." Professor Xanthor finally moved, his upper facets rotating slowly, a gesture of deep consideration among his kind. "Cadet Lee," he said, his crystalline voice resonating throughout the laboratory. "You have taken perhaps the most basic of chemical interactions and elevated it through precision and contextual awareness. While your fellow students focused on creating isolated systems of increasing complexity, you created a system that adapted to and incorporated its surroundings." He turned to address all the students. "This is the essence of true chemical mastery, not merely controlling reactions, but understanding how they exist within and respond to the broader environment. A chemical process does not occur in isolation, no matter how sophisticated our containment systems." Mara could hardly believe what she was hearing. Rather than dismissing her demonstration as primitive, Professor Xanthor seemed to be praising it. "I am reconsidering certain assumptions," the professor continued, his facets shifting in patterns that the translator didn't fully capture. "Perhaps there is value in revisiting foundational principles with fresh perception." The remaining demonstrations proceeded, but a subtle shift had occurred in the laboratory. The students who followed Mara approached their presentations with more thoughtfulness, several of them acknowledging how their reactions interacted with the broader environment, rather than focusing solely on the isolated spectacle. When the evaluations concluded, Professor Xanthor announced that he would consider all demonstrations and provide individual assessments within one standard day. As the students began to disperse, Mara carefully dismantled her apparatus, storing the components for future use. "Terran," came Kellis's crystalline voice from behind her. "Your demonstration was unexpected." Mara turned to face the Zelvan student, unsure whether this was the prelude to more mockery. "Thank you," she replied cautiously. "I have studied 17 chemical systems across 12 galaxies," Kellis continued, his crystalline structure vibrating in patterns that suggested uncertainty. "Yet, I have never considered that such a simple reaction could be orchestrated with such precision. It is thought-provoking." Before Mara could respond, Triz approached, his gelatinous form rippling with bioluminescent patterns. "The way your carbon dioxide release interacted with the residual elements from my crystals, that was not coincidence, was it?" the Vorian asked. Mara allowed herself a small smile. "Not entirely. I observed the spectral properties of your crystals during your early testing and calculated that any residual emissions would likely interact with carbon dioxide in visible wavelengths. I didn't anticipate the accident, but my system was designed to incorporate environmental elements." "Fascinating," bubbled Triz, his inner currents forming patterns of genuine interest rather than mockery. "Most of us work to isolate our reactions from outside influences. You deliberately created a system that becomes more complex through interaction. It's a very human approach," Mara explained. "On Earth, we've always had to work with our environment rather than trying to completely control it. Our chemistry evolved from observing natural processes and finding ways to work within them, rather than transcending them." By the time Mara returned to her quarters that evening, word of her unusual demonstration had spread throughout the academy. Students from other laboratories sought her out, asking questions about her methodology and the principles behind her approach. For the first time since her arrival, Mara felt that she was being seen as a scientist, rather than merely a representative of a primitive species. The next morning, Professor Xanthor's assessments were delivered to each student's personal terminal. Mara hesitated before opening hers, still not quite believing that her simple acid-base reaction could have made a meaningful impression. The assessment began with standard evaluative metrics: technical execution, theoretical foundation, practical application, all of which rated her demonstration highly. But it was the personal comment from Professor Xanthor that caught her attention. Cadet Lee's demonstration represents a significant reconceptualization of fundamental chemical principles. While utilizing reactions that would be considered elementary on most worlds, she has demonstrated that mastery lies not in the complexity of the chemicals employed, but in the depth of understanding and precision of application. Her work suggests valuable approaches for chemical systems that adapt to and incorporate environmental factors rather than remaining isolated from them. This perspective may have far-reaching implications for several fields of study. I am recommending Cadet Lee for a special advisory position with the Intergalactic Chemical Council's Division of Adaptive Systems, where her unique approach may provide insights that more conventional methodologies have overlooked. Mara read the assessment 3 times, hardly daring to believe it. The Intergalactic Chemical Council was the highest authority on chemical sciences in known space. For a first-year cadet, especially a human one, to be recommended for any position within the council was unprecedented. Her terminal chimed with an incoming communication. It was from Professor Xanthor himself, requesting her presence in his private laboratory at her earliest convenience. Mara quickly changed into her formal academy uniform and made her way through the rotating pods to the faculty section. Professor Xanthor's laboratory was larger than the student facilities, with equipment that hummed with energies Mara couldn't identify. The Zelvan professor was examining a holographic display of molecular structures when she entered. "Cadet Lee," he acknowledged, his crystalline form shifting to face her. "Thank you for coming promptly." "I was honored by your assessment, Professor," Mara said, still not entirely sure why she had been summoned. "It was accurate, not honorific," Xanthor replied. His facets rearranged themselves into what Mara had learned to recognize as a contemplative formation. "I have been teaching at this academy for 327 standard years. In that time, I have observed many brilliant minds, many innovative approaches, yet rarely have I been forced to reconsider my own fundamental assumptions." He gestured to the holographic display, which shifted to show a recording of Mara's demonstration. "Your approach reveals a blind spot in our advanced chemical philosophy. We have become so focused on developing increasingly exotic and complex chemical systems that we have neglected the adaptive potential of simpler reactions." The display zoomed in on the interaction between Mara's carbon dioxide release and the residual elements from other students' projects. This integration, this harmony with the surrounding chemical environment, is something we have overlooked in our pursuit of isolated perfection. "On Earth, we've always had to adapt," Mara explained. "Our planet's chemical systems are chaotic, interconnected. We learn to work with that chaos, rather than trying to eliminate it." "Indeed." Xanthor's crystalline structure vibrated with what seemed like approval. "And there may be significant advantages to such an approach, particularly in environments where complete control is impossible or impractical." He manipulated the holographic controls, and the display shifted to show a star system Mara didn't recognize. The Council is currently facing challenges with chemical stabilization in newly terraformed environments. Traditional approaches, focusing on isolated chemical systems, have proven insufficient. Your adaptive methodology may offer new insights. Mara stared at the display, hardly believing what she was hearing. "You want me to consult on a terraforming project? But I'm only a first-year cadet. Your status is irrelevant. Your perspective is what matters. Xanthor's facets shifted again. The Council has reviewed your demonstration and agrees with my assessment. They have requested your participation as an advisory consultant, working alongside their senior scientists. You would, of course, continue your studies at the Academy, but with a modified curriculum that accommodates this additional responsibility. Mara felt momentarily overwhelmed. 6 months ago, she had arrived at the Academy hoping merely to prove that humans weren't hopelessly backward compared to other species. Now she was being offered a position that senior scientists would compete for. "This is unexpected," she managed to say. "As was your demonstration," Xanthor replied, with what might have been the Zelvan equivalent of dry humor. "Consider it carefully. Such a position would place you under considerable scrutiny. Not all council members share my appreciation for your approach. Some will expect you to fail." "They've been expecting me to fail since I arrived," Mara said with newfound confidence. "I accept the position." "Excellent." Xanthor's crystalline structure vibrated in a pattern that suggested satisfaction. "You will receive the formal appointment and project details within the day. I will adjust your academic requirements accordingly." As Mara turned to leave, Xanthor added, "One more thing, Cadet Lee. I admit I had my doubts about admitting human students to the Academy so soon after your species' development of interstellar travel. I believed your chemical understanding was too rudimentary for meaningful contribution." His facets shifted in a pattern Mara had never seen before. "I am pleased to have been proven wrong." When Mara returned to the student laboratory later that day, she found Kellis, Triz, Vorn, and several other students gathered around her workstation. For a moment, she feared they had come to mock her, but their body language, as varied as their species, suggested curiosity rather than derision. "Is it true?" asked Triz, his gelatinous form rippling with excitement. "You've been appointed to the Council's Adaptive Systems Division?" News traveled fast in the Academy. "As an advisory consultant, yes," Mara confirmed. "That is unprecedented." Kellis vibrated, his crystalline structure displaying patterns of astonishment. "No first-year cadet has ever received such an appointment." "The professor says my approach offers a different perspective," Mara explained, still somewhat uncomfortable with the sudden attention. "We have been discussing your demonstration," said Vorn, the Trelax student's tentacles gesturing toward the group. "Your integration of environmental factors was something none of us considered. We have been trained to isolate our reactions, to create perfect, controlled systems. But reality is rarely perfect or controlled," added Triz. "Perhaps there is wisdom in embracing complexity rather than trying to eliminate it." Mara looked at the assembled students. Representatives of civilizations thousands, or even millions of years more advanced than Earth's. Yet, they were looking at her not with mockery, but with genuine interest. Perhaps even respect. "On Earth, we have a saying," she told them. "The perfect is the enemy of the good." Sometimes, working with imperfection leads to more robust solutions than striving for an unattainable ideal. "A primitive but surprisingly insightful concept," Kellis admitted, his crystalline structure vibrating in what Mara was beginning to recognize as thoughtful consideration. Over the next few weeks, Mara's position within the Academy transformed. Students who had once dismissed her now sought her input on their projects. Several began experimenting with more adaptive approaches, designing chemical systems that worked with environmental factors rather than against them. Professor Xanthor incorporated elements of this philosophy into his lectures, using Mara's demonstration as a case study in how fundamental reactions could be orchestrated to create complex, responsive systems. Other faculty members began to take notice, and soon, Mara found herself invited to speak in advanced classes about the Terran adaptive approach, as it had come to be called. Her work with the Council's Adaptive Systems Division began with virtual consultations, reviewing ongoing terraforming projects, and offering suggestions for how more adaptive chemical methodologies might address persistent issues. At first, many of the senior scientists were skeptical, but as Mara's recommendations began to show promising results in simulations, attitudes slowly shifted. 3 months after her demonstration, Mara received a communication from the Council requesting her presence at their central facility on Zelvin Prime for a direct consultation on a high-priority project. Professor Xanthor arranged for her academic responsibilities to be adjusted, allowing her a 2-week leave to fulfill this request. On the evening before her departure, Mara stood at the viewport in her quarters, looking out at the stars. Somewhere out there, beyond the Academy's rotation, was Earth, the planet whose primitive chemistry had just earned her a consulting position with the most prestigious scientific body in known space. Her terminal chimed with an incoming message. It was from her parents back on Earth, responding to the news she had sent them about her appointment. Their faces appeared on the screen, pride evident in their expressions. "We always knew you would show them what humans are capable of," her mother said, her eyes bright with emotion. "Your grandmother would have been so proud." "It was her volcano experiment that inspired me," Mara admitted. All those weekends in her kitchen, mixing baking soda and vinegar, watching the foam rise. She always said the simplest reactions often teach the most profound lessons. She was right, her father added. And now you're teaching those lessons to beings from across the galaxy. After saying goodbye to her parents, Mara carefully packed the equipment she would need for her consultation. As she prepared for bed, her gaze fell on a small display case on her desk. Inside was a miniature version of her demonstration apparatus, a reminder of how a reaction considered childishly simple on Earth had changed her place in the Academy and, perhaps, the future direction of intergalactic chemical science. Tomorrow, she would board a ship to Zelvin Prime, where she would sit at a table with some of the most brilliant chemical minds in known space. She would speak, and they would listen, not because she came from an advanced civilization or had mastered exotic chemical manipulations, but because she had found depth and potential in the most fundamental of reactions. As the Academy's lighting dimmed for night cycle, Mara smiled to herself. Perhaps being primitive wasn't such a disadvantage after all. Sometimes, the oldest, simplest approaches revealed truths that complexity obscured. And in that understanding lay a kind of wisdom that even civilizations, millions of years ahead of Earth, had yet to fully appreciate. The universe, like chemistry, was not about isolated systems of increasing complexity. It was about connections, adaptations, the intricate dance of elements responding to one another. And in that dance, even the simplest partners had crucial roles to play. Mara closed her eyes, dreaming of white foam rising through spiral tubes, of carbon dioxide creating patterns in the air, of the expressions of amazement on alien faces. Tomorrow would bring new challenges, new opportunities to demonstrate the value of the Terran perspective. But for tonight, she would rest in the knowledge that she had already accomplished something remarkable. She had taken baking soda and vinegar, the components of every child's first science experiment, and used them to change the thinking of some of the most advanced minds in the galaxy. As she drifted off to sleep, Mara whispered a thank you to her grandmother, whose kitchen experiments had set her on this path. "You were right, Grandma," she murmured. "Sometimes the simplest things really do contain the most profound truths." Across the vast distances of space, on planets circling stars of every size and color, beings with bodies of crystal, gel, gas, and countless other forms continued their scientific pursuits. But something had changed. A new perspective had entered their collective consciousness. A reminder that sometimes the path to innovation lay not in increasing complexity, but in finding new depth in the fundamentals. And it had all begun with a human cadet, a handful of baking soda, and a bottle of vinegar.